Hey guys, I want to talk a bit about how Doppler works. Hopefully you watched some of the videos on it. It's on the AP1 big review on Quest. So it's not on the AP test, but it is on that thing, and so some people want to be able to work these problems. So this is the equation. This is what it looks like. And of course, Doppler is that change in frequency that you hear when something is moving, right? So if a car drives by, it goes, right? Well, the car doesn't actually make that noise. So if you're sitting in the car, you're hearing a constant engine sound, as you're driving. But to someone on the side of the road, they're going to hear this higher pitch as it coming towards them, and then a lower pitch as it goes away from them. So it goes, right? So anyway, F prime is what you hear, okay? F is the actual frequency. That's the actual sound that whatever it is making. Maybe it's a car, something like that, okay? I set this up just like this every time for every Doppler problem. The 340 is the speed of sound in air, or 343. Whatever the problem says the speed of sound is, that's what you're going to put both bottom and top. And it's plus minus on the top and minus plus on the bottom. I'll get to that in a minute. Vd is the velocity of the detector. This is the person hearing the sound. So in my previous example, if it's a person standing on the side of the road, then that would be the person. That would be Vd. Vs is the velocity of the source. This is what's making the sound. So in that case, it would be the car driving by. Okay, so you set it up like this every time. These are actually really easy problems once you see a few because they don't change a whole lot. Now, I know what you're thinking. Plus, minus, and minus, plus. It's like, geez, Sharkey, make up your freaking mind. That's what you're going to have to do for every problem is you have to decide which sign to use. And here's the rule of thumb. You use the top sign when something is going towards something else. So on this top part, if something is going towards the detector, then you would use the plus sign. Down here, if something is going towards the source, you would use the minus sign. That's what top equals towards means. Bottom equals away. So you'd use the bottom sign if something is going away from something else. So up here, you'd use the bottom, you'd use the minus sign if something is going away from the detector, and you would use the plus sign down here if something is going away from the source. So this is how these problems work. What I'm going to do now is I'm going to work the first problem on the practice problems that are in the module. Alright guys, so we're going to work this first problem. If you got it pulled up, it's about cops and robbers. So the cops are chasing a couple of bank robbers in a car. Cops are going east at 50 meters per second. Robbers are going east at 30. So I drew a little picture. This is my setup. Math is usually about the same. The only number that would change would be the 340 depending on what the waves are moving in. This is the speed of sound in air. So anyway, part A wants to know what would you hear if you were standing on the side of the road, right? So if you are a stationary observer standing on the side of the road, what would you hear? So we're looking for F prime. Okay. F is the actual frequency. And the sound is the siren from the cop car, and the problem tells us that it's 1200 hertz, right? Okay, I'm going to go ahead and set up the next part. There we go. Pretty much looks the same every problem. All right, Vd is the velocity of the detector. That's the person, that's you, standing on the side of the road. So if you're just standing, then your velocity relative to everyone else would be 0. There you go. Vs is the velocity of the source. What's the source of the sound? Well, it's the siren, top of the cop car. The siren on the cop car is moving at 50 meters per second. So that's how you do that. You got to work through it. You got to think about it. Okay. Now, the only other thing to do is to figure out which signs to use up here and down there. Okay. So the detector, is it moving towards or away from the cop car? Well, the detector is actually standing still. So they're not doing either. Here it doesn't matter. 340 plus 0 is the same as 340 minus 0. So actually, we don't care. So on the top, you just have 340. The bottom, this is the source. That would be the cop car. Is the cop car coming towards you, or is it going away from you? Well, cop car in this sense is coming towards you. If you read the problem, the cops are coming at you. And so the top sign down here would be this minus sign. So we're going to use the minus sign. So it'll be 340 minus 50. $340 minus 50, 290. And so now you have this fraction. This fraction is going to be greater than 1. And what you should hear, if the cop car is coming at you, you should hear a higher pitch as it's coming at you. So what will happen is when we take something greater than 1 and multiply by this, we should get a larger number, right? And so this will end up getting us something that is 1,406 hertz. Right? So you're going to hear a higher pitch. Okay? And that's how that works. Alright guys, so part B asks, well, what would you hear if both cars pass you and now they're going away from you? So same setup. You are still standing by the side of the road, not moving. The cop car is still the source of the sound. It's what's making the noise. So everything's the same except the signs are different. 340 plus 0 is the same as 340 minus 0. Now on the bottom here, now the cop car is moving away. So instead of using the minus sign, we're going to use this plus sign. So it'll be 340 plus 50. $1,200, 340, 390. So what happens here is now you get a small number. This is a fraction less than 1. When you multiply that number by something less than 1, you should get a smaller frequency. So as the cops go away from you, that's when the pitch goes down. And so you should get something less than 1,200. It's 1,046 hertz. It's going to be less. That kind of makes sense. Alright guys, part C is a little bit different. It wants to know, what do the robbers hear in their car? Right? As they're being chased by the cops, what do they hear? So this one's a little tricky because now everything's going to be moving. The cop car is moving. The robbers are also moving. So we set this up, trying to figure out what do they hear. Frequency of the cop car is the same. Who is detecting the sound? It's the robbers. And they're moving at 30 meters per second. What's making the sound? What's the source? It's the cop car. 50 meters per second. Okay? Now we got to figure out what signs do we use, and this is always tricky for folks. So at the top here, are the robbers moving towards or away from the cops? Well, cops are going this way, but robbers are going that way too. Robbers are trying to get away from the cops. Robbers are trying to get away. Robbers don't go towards cops, guys. We're going to use the bottom sign here. So on that side, it's going to be, on the top, it's going to be 340 minus 30. Bottom, what are the cops doing? Well, the cops are trying to catch them. Cops are trying to go towards them. So that'll be the top sign down here. So it turns out they just happen to both be the minuses. That doesn't always happen. We got to do our math. Still 1200. 340 minus 30 is 310. 340 minus 50 is 290. This makes a bigger, this fraction, excuse me, is bigger than 1. So we multiply it by 1200. We should get a bigger number. And the answer ought to be a little more than 1200. It's like 1280. 1282 hertz. So the robbers are going to hear a higher pitch. And the reason is because the cops are gaining on them. The cops are going faster. The robber's car is probably loaded up with all their loot, so they can't go as fast. Should have thought about that, right?